The Oort cloud is thought to be a remnant of the original protoplanetary disk that formed around the Sun approximately 4.6 billion years ago. The most widely accepted hypothesis is that the Oort cloud's objects initially coalesced much closer to the Sun as part of the same process that formed the planets and asteroids, but that gravitational interaction with young gas giant planets such as Jupiter ejected the objects into extremely long elliptic or parabolic orbits. Simulations of the evolution of the Oort cloud, from the beginnings of the Solar System to the present, suggest that the cloud's mass peaked around 800 million years after formation, as the pace of accretion and collision slowed and depletion began to overtake supply. Gravitational interaction with nearby stars and galactic tides modified cometary orbits to make them more circular. This explains the nearly spherical shape of the outer Oort cloud. On the other hand, the Hills cloud, which is bound more strongly to the Sun, has yet to acquire a spherical shape. Recent studies have shown that the formation of the Oort cloud is broadly compatible with the hypothesis that the Solar System formed as part of an embedded cluster of 200 to 400 stars. These early stars likely played a role in the cloud's formation, since the number of close stellar passages within the cluster was much higher than today, leading to far more frequent perturbations. Comets are believed to have two separate points of origin in the Solar System. Short-period comets, those with orbits of up to 200 years, are generally accepted to have emerged from the Kuiper Belt or scatter disk, two linked flat disks of icy debris beginning at Pluto's orbit at 38O and jointly extending out beyond 100O from the Sun. Long-period comets, such as Comet Hale-Bopp, whose orbits last for thousands of years, are thought to originate in the Oort cloud. The orbits within the Kuiper Belt are relatively stable, and so very few comets are believed to originate there. The scattered disk, however, is dynamically active and is far more likely to be the place of origin for comets. Comets pass from the scattered disk into the realm of the outer planets, becoming what are known as centaurs. These centaurs are then sent farther inward to become the short-period comets. The precise origins of the Kuiper Belt and its complex structure are still unclear, and astronomers are awaiting the completion of several wide-field survey telescopes such as Pan-STARRS and the future LSST, which should reveal many currently unknown KBOs. These surveys will provide data that will. The Kuiper Belt is believed to consist of planetesimals, fragments from the original protoplanetary disk around the Sun, that failed to fully coalesce into planets, and instead formed into smaller bodies, the largest less than 3,000 kilometers in diameter. Modern computer simulations show the Kuiper Belt to have been strongly influenced by Jupiter and Neptune, and also suggest that neither Uranus nor Neptune could have formed in situ beyond Saturn, as too little primordial matter existed at that range to produce objects of such high mass. Instead, these planets are believed to have formed closer to Jupiter and migrated outwards during the course of the Solar System's early evolution. Eventually, the orbits shifted to the point where Jupiter and Saturn existed in an exact 2:1 resonance. Jupiter orbited the Sun twice for every one Saturn orbit. The gravitational pull from such a resonance ultimately disrupted the orbits of Uranus and Neptune, causing Neptune's orbit to move outward into the primordial planetesimal disk, which sent the disk into temporary chaos. As Neptune traveled along this modified orbit, it excited and scattered many TNO planetesimals into higher and more eccentric orbits, depleting the primordial population. Objects in the belt: Pluto, former 9th planet, now a dwarf planet; Oumuamua, dwarf planet 1/3 the mass of Pluto; 90482 Orcus, a potential dwarf planet; 50000 Quaoar, a potential dwarf planet, and many more. The scatter disk, or scatter disk, is a distant region of the Solar System that is sparsely populated by icy minor planets known as scattered disk objects, SDOs, a subset of the broader family of trans-Neptunian objects, TNOs. The scattered disk objects have orbital eccentricities ranging as high as 40 in perihelia greater than 30 astronomical units. These extreme orbits are believed to be the result of gravitational scattering by the gas giants, and the objects continue to be subject to perturbation by the planet Neptune. Make a dwarf planet. It is the third largest known dwarf planet in the Solar System. Eris, the largest known dwarf planet in the Solar System. Dysnomia, moon of Eris, 90377 Centaur, object of mystery. Well, Senda's tricky. While it is in the disk, its orbit indicates that it was actually a part of the Oort cloud. Why, yes, there are more objects just as cool. One of them is the asteroid belt,